One thing that has happened in U.S. manufacturing, I would say, my colleagues tell me, don't use this phrase, but I like to use it anyway, which is injecting. That is a bit of a caste system that has developed.
If you don't believe that additive is one of our futures, then you're living in a bubble.
It will change your company. There's no doubt about it.
Welcome to Smart Manufacturing Magazine's latest Collective Intelligence Roundtable, zapping waste in aerospace machining in a time when there is no room for it. This roundtable is sponsored by Sandvik, Coromant. The pandemic is causing a more intense focus on the need for not only the kind of alacrity achieved with digital tools, but also the kind of smart achieved with strong partnerships. You want tools that talk to you while you are working, especially when it comes to machining high-cost aircraft components. You need to use data to identify problems, find solutions, and make decisions faster than ever before. Dale, how do we bring Digital 4.0 to the shop floor?
Always try to tell our customers that you can start small with just some basic machine tool monitoring. Just say if you put sensors on the spindles, you can check for spindle load, check for spindle vibration, and do the simple things like
I believe today to bring the 4.0 industry to the shop floor is all about exactly the digital tools that we can use. And for that, it's all about the simulation software as well.
Could you please address what the advantages and the disadvantages are of digital tooling?
Clearly, with digital toolings, we can get higher degrees of accuracy, a more predictable performance. In my experience, it becomes harder and harder to troubleshoot and get to the root cause if something does go wrong.
Then it's extremely important to be successful to link all those little data together.
So would you please go over what the main pain points are involved with introducing digital tooling?
The first pain point I could see is the integration into the existing architecture. The second challenge I could see really is like information security. And then the third would be support models.
That doesn't mean that subtractive or machining processes go away. I strongly believe from everything I've seen that they actually become complementary.
There's no reason for an engineer, a younger engineer, not to jump all over solid modeling, 3D models. We supply them for free. We are trying to bring every bit of information the operator needs to run that part down to the shop floor.
We are starting a new program in rapid prototyping and additive manufacturing. And then there is going to be a center of excellence within Oregon Manufacturing Innovation Center working with industries.
It's all about, again, finding the best compatibility between design, raw material, and manufacturing process.
To look at your entire manufacturing process and identify where's your bottlenecks and where you could benefit from digital tooling, whether it be production benefits or quality benefits.
And you could take that overview from the 45,000-foot view and see immediately where are my bottlenecks. You can go back in time, look at the data that's accumulated.
We have created a bit of a disconnect, and when it comes to areas like manufacturing, it becomes a disadvantage to industries.
Right, you mentioned HMI, I guess, human machine interface. How much has that improved in the last, say, 5 years?
Tremendous. There are so many good interfaces and ways to get information out of your facility now that can go directly to the control.
Just like manufacturing 4.0, there is education 4.0 we have to build.
Invest in the people. I think everything falls in place from there.
Well, thank you all for joining us today. We really appreciate your time, and have a wonderful day.
Thank you.
Thank you.